Good evening, everybody. This is Obi-Wan Bez Varen Simplex Pachinko, and we are going to be doing some math tonight. So, I have the cracking the GRE math test from the Princeton review that I used back in 2002, and I figured, yeah, why the hell not? So I think at some point I probably have run through at least like, a chapter or two of this. But we'll start, I think, from the beginning. And we could probably get through most of the precalculus tonight. All right. On Excalibur. Oops. Okay. If we go into the precalculus section, the very basic stuff that we talk about in precalculus is, generally speaking, that you're going to have these things which are called functions. Which are going to assign which are going to assign elements of one set to another. So generally speaking, we say that a function is going to be that rule, which is then going to assign elements of set A onto asterisk elements of set B. We have to be very careful about the actual words we pick because they do mean something. So the word onto really does mean that, like, all of the elements of one thing are going to be put onto another, or are going to be mapped to like an entire new set. So I'm gonna pop the music down a little bit here. All right. Alright, so we have rules, which are going to assign elements of one set to elements of another. Normally we say something like X is going to be an element of A and Y is going to be an element of B. Such that f of x is going to be equal to y. Alright, this also can be written as x being mapped to y through function f. Again, generally speaking, we call these mappings. Um, A is going to be the domain, which is a set, which is going to contain all valid inputs of F. And B is going to be the range, which is a set containing all received output values of F. Now, generally speaking, these are only going to have valid input values for F as the domain, and only going to have received output values for the range. However, sometimes you can end up with sets which are larger than that. They just happen to contain all of the... it's not a minimal set. It doesn't have to be a minimal set. So it can contain all of the valid inputs of F in order to get to the domain. You can contain all of the received output values of F in order to be the range. I don't particularly like it if, for instance, somebody were to say that the output of the square root function would be all real numbers. Just because, in that case, yeah, sure, the range set can be all real numbers, and you're only going to end up using those which are non-negative. You're only actually going to receive back those which are non-negative. But I find it more helpful to try and state for the domain and range the minimal set for which we have only all valid inputs of F for the domain and only all received values, output values for the range. All right, Y is generally called the image. And usually we say that Y is going to be the image of X. So if the range is different, it's a different function. So, I mean... so, like, if you're just talking about the real numbers, right, then the square root function is going to get you only, all real numbers being input into the square root function. Oh, look at that. We can't really do that because we don't get real numbers out. So usually we say, okay, we're going to pare this down to the stuff that's only going to get us real values. So things that go in, which then get us real values out, are going to be just in the first quadrant, all of our non-negative inputs and non-negative outputs. If you were to say, I want the square root function, but this time it's going to be on the complex numbers, well, now you have no restrictions. You can plug in any complex number you want into the square root function, and you will get a complex number back out. And in fact, that's going to be a little bit tricky because now we're saying, okay, are we only doing the principal root? or are we including other roots as well? It's like, how are we going to do that? Sometimes it can get a little tricky. But you have to define what domain or range you're going to be. You can define your range based on the inputs that you are allowing. So what is going to be your domain set? And then once you figure out what your domain set is, what are the consequences of that? What's going to create the range set? I've pretty much exclusively been working with real numbered sets, or real numbered domains and ranges. So, you know, if there's a little bit of bias there that somebody is going to be like, oh, that doesn't quite work that way, I'll take it. Oh man, my vocabulary. Alright, so surjective is where you're mapping forward. Injective is backwards, B onto A. That's a question. Okay. Injective is 1-to-1. Okay. It feels like it should be bijective. So how do we get a set that is surjective but not injective, right? Does that just mean there's extra elements that are not valid to be plugged in? Need the surjective parts. The inverse can be defined on all of B. Oh, right. Okay. Yeah. That makes sense. Right. So B is going to be equal to the image of A exactly, whereas injective just means that there is a 1-to-1 correspondence. That's not proper mathematical notation, but... Alright, A is 1-to-1 with B, which only says... right, which only says there is a 1-to-1 correspondence. B can be bigger, which is also saying that image of A can be a subset of B. Yep. I mean, this is also coming down through the generations of other mathematicians who named things, maybe not in the most efficient way. I'm trying to remember, right? C, that time when things got named the same thing, but mean completely different things. Okay, so consider the real valued function f defined by the equation given here. F of x is equal to the negative square root of x plus 1 over absolute value 2x plus 1 minus 1. Determine the largest subset A as a subset of the real numbers for which A is the domain of F and B at point x0, which is in the domain of A. Nope. Domain of F. X0 is a fixed point. If f of x0 is equal to x0 itself. This function has exactly one fixed point. What is it? Find out what is the largest subset of the real numbers for which it is the domain of f. So in here, we know a couple of things. One is that x plus 1 over absolute value 2x minus 1 must be, or must exist, such that everything inside of the square root function is going to be greater than or equal to 0. Which also means that since the absolute value at the bottom is always going to be positive, we can multiply that across, and we just get x plus 1 is greater than or equal to 0. Which means that x is greater than or equal to -1. So our domain of f is going to, nope, going to be equivalent to meh. Let's just do colons here. That's fine. Set-builder notation. X such that x is greater than or equal to -1, or we could do this in interval notation. Going to go from -1 on up to positive infinity. Okay, this particular function right, f of x is equal to negative square root of x plus 1 over absolute value at 2x minus 1 is going to be defined with f of x sub 0 is equal to x sub 0, which is equal to negative square root x0 plus 1 all over absolute value 2x0 minus 1. Alright, so for this, we're going to bring the negative over, but then we're going to square both sides. So, it doesn't much matter there. We're still going to get x0 squared is going to be equal to x0 plus 1 over absolute value 2x0 minus 1. We're going to multiply both sides by the absolute value, and so we get x sub 0 squared multiplied by the absolute value of 2x0 minus 1 is equal to x0 plus 1. Alright, x squared is always positive, so it's equivalent to the absolute value of x squared, x0 squared. So we can make this the absolute value of 2x sub 0 cubed minus x sub 0 squared is equal to x sub 0 plus 1. Right, and then we can try and solve this cubic either for the positive or the negative values that we get out of this. Right, so this is going to be 2x sub 0 cubed minus x sub 0 squared is equal to x sub 0 plus 1. Or we can get a negative 2x sub 0 cubed plus x sub 0 squared is equal to x sub 0 plus 1. And so at this point we can try and solve either of these. This one's going to be a 0 is equal to a positive 2x cubed minus x0 squared plus x0 plus 1. The other is just what we see. Right, we can move the x0 and the 1. So 2x0 cubed minus x0 squared minus x0 minus 1 is equal to 0. Okay. So, going from Descartes' rule of signs, we can look at this real quick and see that there is one sign change for the first one. Hey, Zach. How's it going? And two sign changes on the second for the positive side. So this says that we're going to have at most we're going to have one real value such that x of 0 is going to be greater than 0. Here we could have either 0 or 2 real solutions such that x0 is greater than 0. Right. If we try and go for the negative side, that's going to switch the signs of all the odd terms, and so we end up with 1, 2 sign changes here. Or potentially none. Such that x0 is less than 0. On the other side, right, and we change the signs of all the odd terms. This is going to get us exactly one sign change, so 1 real such that x0 is less than 0. Shouldn't really be a surprise here, right? In every case, the maximum number of zeros has to add up to be the degree of the polynomial. So in this case, it has to add up to 3 at most. Right, let's trade that for green. Because that's how we changed it. Right, so that's not really helping just offhand. And then we want to solve the actual equation to see if we can do something helpful. Doesn't look like we're going to get anything out of grouping, because again, here we get a 2 and a 1 for its coefficients, and then a 1 and a 1, so not so much. At this point, we can go over to Desmos and check it. There are other better ways to go through it, but if you're in a GRE, right, don't waste your time. Oh, third. 2x cubed. Got this Catalan number thing in the way. Minus, minus, minus. Right. So we do end up getting one particular value there. And then on the other side, we've got positive, negative, positive, positive. And we get a nice value. So the other one, 1.23375. Anybody recognize that? It's a nice square root. Not particularly. Alright, so we do have at least a negative 0.5 as an answer. And again, the other one is almost certainly irrational. Can't think offhand what that's going to be, but could also figure it out. Probably use Wolfram Alpha to get the closed form. There is one. It's just a matter of figuring it out. It could also be really disgusting because the cubic function, when you do it out, doesn't have to be nice. Quite possibly. Mm-hmm. Right, if we plug a negative 1/2 in for x, then we're going to get a negative 1/2 plus 1 is still 0.5. Yep, and in the denominator, this is at least going to be reasonable here, right? Because we take the absolute value, that's always going to be positive. Left-hand side, we assumed that 2x plus 1 is greater than 0. Yeah, that's a good point. Right, this one is going to get us that x was going to end up being less than 1/2, and we ended up with a value that x sub 0 needed to be negative 1/2 exactly in order to make this work. So that one does seem like it works. It's also less than 1/2, so we're good on that one. This one is going to say that x needs to be greater than 1/2. And we ended up with a 1.23375. Right, so that's potentially going to cause a problem. Alright, so let's actually plug this stuff in. And see what happens when we Right, this was 1.23375 is equal to a negative square root. Well, I think that just about clears it up. So, no, right? That can't happen in the first place. So we can stop there immediately. All right, this side's going to be positive. This side's going to be negative. Right, can't happen. This one, on the other hand, we get a negative 1/2 is equal to negative square root negative 1/2 plus 1 divided by absolute value 2 times a negative 1/2 minus 1. So negative 1/2 is equal to negative square root of, that is 1/2, negative 1/2 plus 1 is going to be a positive 1/2, divided by, at the bottom we have a negative 1 minus 1 is going to get us a negative 2. Take the absolute value and we get a 2. Looks much better already. Multiply both top and bottom by 2 within the square root, and we end up getting that this is going to be negative negative square root of 1 over 4, which is indeed negative 1/2. So yeah, x0 is equal to negative 1/2 is the only solution that is going to work, the other one being on the wrong side. Okay, so why does that work? Why does it do that? Why do we end up with a positive on one side and negative on the other? Well, that's because up here we took this square root thing and we squared both sides. So we move that negative to x of 0 first, and then we squared. When you square a negative, we end up getting a positive. So now that, the problem as a whole doesn't recognize that you might have had a negative to start with. When you square it, it loses that information. Yeah, also true. We could have said when we did this Descartes' rule of signs stuff, right, that because we had a negative right, it was either going to be 0 or 2, but like this said, there is only one answer. So looking at this, if you have 2 real numbers for which this works, something else must be breaking it. And likely, if that was actually the case, if we ended up with 2 real negative numbers that fit, it's possible that one of them could have broken the other rule that we had, that our absolute value of 2x minus 1 had to be, or 2x minus 1 had to be greater than 0. So it could have been, potentially, a slightly different manner of looking at it. Yep. Right. Yeah. Contradiction. Similar on the other side, right? Well, we can't do that actually, because here we might have a positive real that's between 0 and 1/2. So in theory, that could have worked. In theory. Anyway, yes. X sub 0 is going to be equal to negative 1/2 in order to make that work. Woohoo! Right. Any questions? Okay, if we do function composition, so f of g of x is equal to, in this case, the f of g, all of x, the of part there, the composition of the two functions denoted by that open circle right in the middle. So it is going to be important to make sure that you have the right one and you don't mistake f of g for g of f, because it can happen all the time. It's like the big thing that everybody warns you against. Usually the best way to think about it is to start saying like, okay, what's our shell function? What's the thing on the outside that's going to be the structure of the overall function? In this case, it's f, which is x squared. But instead of plugging in an x into the square function, here we're going to be plugging all of g. So all of g needs to be inserted into the square function f. Right, and that would be fine if we're mostly looking for like function composition. If we need to plug in values and stuff like that, it becomes a different problem. It's fine. But in general, if you multiply this out, we're going to get x squared plus 14x plus 49. Whereas g of f of x is going to look like a thing plus 7. Right? G is the overall structure of this particular composition, and then f is being placed in totality inside of the g function. So in this case, we just get x squared plus 7. So you can see how these are quite different. and the order in which you apply things can have quite a big difference, make quite a bit of a difference in what our result is. So if we wanted, again, something like f of g of 3, then we're going to take 3 plus 7 and then square it is going to get us 10 squared is going to be 100. Whereas if we did g of f of 3, we end up getting x, which in this case is 3 squared, plus 7, which is going to be 9 plus 7, which is going to be 16. So again, very different processes, very different objects. You want to make sure you know which one's which and which one you need for any particular scenario. Okay. Example given. Consider functions f and g such that f of x is equal to, nope. F of g of x is equal to square root of x squared plus 1 minus 1. Right, if g of x is equal to x squared plus 1, then what is the value of f of 4? Right, so this is reverse engineering the f function. Not terribly difficult, but nonetheless, it's something to make sure you don't want to get it terribly confused. Or do something. Do something that is going to throw everything off. Oh. Sorry, my count is off by 11 minutes on either of my computers. It's weird. So here, if g of x was x squared plus 1, then we can replace that inside of that particular setup. And then we have this, and that means that f of x rather than f of g of x is going to be the square root of x minus 1. Okay, therefore, f of 4 is going to be equal to the square root of 4 minus 1. Square root of 4 is 2, minus 1 is going to be 1. Hey, Trenton. Well, this is GRE, and granted we are doing the precalculus section. So if you've ever done like function analysis type stuff, most of Algebra 1 is function analysis. I'm doing alright, how are you? So, yeah, this would have been... They would have touched on it. This is the GRE math. So it does touch on other stuff at much higher level. All right, let f and g be real valued functions defined for all real numbers such that f of x is equal to g of x squared minus 1 and g of x is equal to x minus 1. So that's going to tell us immediately what to do with these things. This is just the 2002 edition. I took my GRE in 2005, I think, when I graduated from college. As I recall, I did decent. Alright, so f of x is equal to g of x squared minus 1, which is parentheses minus 1. Because again, here, the structure of this bit is still going to be g of x overall. So it's x minus 1, but now the x is being taken out, and then it's all the leftover stuff. This x squared minus 1 as a whole is going to get shoved in here, which is then going to be x squared minus 2. So x squared minus 1 minus 1. X squared minus 2. Okay, so f of x is equal to that. And g of x was always just x minus 1. Okay. Now we want to look at what is f of g of x and what is g of f of x, and then where are those two things equal to each other. So f of g of x, we take f, we say this is going to be something squared minus 2. Again, f is the framework. The outside thing is going to be the framework for how the rest of it looks. And then g of x, which is x minus 1, needs to be plugged in. Going the other way, g of f of x is going to be a framework of g, which is something minus 1. And then the stuff that goes on the inside is going to be f, which is x squared minus 2. So now we want to know when these two things are equal. So x minus 1 squared minus 2 is going to be equal to x squared minus minus 2 minus 1 is going to be x squared minus 3. Well, we don't really need the parentheses there. There's nothing that we're doing that's actually going to separate those terms. So x squared minus 3. All right. We're going to multiply out x minus 1 parentheses squared. We end up with an x squared minus 2x plus 1 minus 2 is equal to x squared minus 3. We're going to subtract an x squared off from both sides. We're also going to add 3. No. On second thought. Yeah, it's fine. We'll add 2x, and we'll add 3. This is just bookkeeping stuff, so algebra. 2x is equal to, over here we've got a 1 plus 3 is 4, minus 2 is going to be 2, and then divide by 2. So x is going to be equal to 1. There was only one possible solution for that, so the only location for which f of g of x is equal to g of f of x is going to be at x equals 1. So it's less going to be thought of as we need to do something in particular with this. Now, there are many different applications for all areas of mathematics. Most of what we're doing here for like this particular practice test is making sure that you understand how the rules of mathematics work in general. So the much larger picture. Rather than necessarily saying like this is going to work in this particular application. We instead say here are the rules for all of it. So rather than worrying about I'm going to move my knight when my king is in check, you're going to say whenever I get in check, I need to do something. If we're going to use a chess metaphor. So all right, ads are about to start in 30 seconds, so we'll take a 3-minute break. Get up, stretch, cycle that water, do whatever you need to, and we will be back. Probably I'm going to hit one of the redeems if nobody else does first. Zach knows he wants to. All right, see you in 3. Thank you for bearing with me for this costume change. Decided to switch to shorts because, goodness, it's getting kind of hot in here. Thank you, Zach, for the redeem. Start with our 20 pounders as usual. And we're just doing regular standard arm curls. Yep, so I taught math at a community college for 15 years. Let's see. Technically, I guess it was a little longer than that. Whatever. Started out as an adjunct professor, and that was 2007. And then, hey, Sir Brenrick, how's it going? I could only teach developmental classes, so I learned how to teach like the basic algebra stuff. Got a taste for coffee. Ended up working with one of the more experienced teachers to try and get my get my profile together, do all sorts of cool stuff. And then in 2010, it was 2011. In December 2010, my spouse and I both finished our master's degrees. Mine was in applied and computational mathematics at Johns Hopkins University, and hers was in computer science at the same. And then I had applied for a full-time position that had come available. One of the guys had been diagnosed with cancer, so he was understandably taking a semester off. So he ended up vacating his position, so they hired me as a temp. Well, as a full-time instructor to try and fill the gap that he had left. There were also two other people who had been hired outright, so they were just on staff anyway. And then in 2023, that was fall of 23 was my last semester at that community college, because my spouse had discussed with us a year prior that a position came available in Yorkshire, United Kingdom. So we've been here for a little over a year, and it's pretty good. Everything's really nice. We try and get out as much as possible. We just got back from a vacation to Scotland. And our kids are both doing scouts and all sorts of cool stuff. So yeah, generally speaking, life's been good. So getting culture and all that. I am finding Yorkshire well. Everybody's very nice and welcoming. We've been going to the Alhambra in Bradford to go watch a bunch of theater shows and stuff like that with the kids. You know, get some culture. Just watched the stage production of Mary Poppins yesterday. Quite good. also quite different from the, the movie that we all grew up with. We've also got a fairly large contingent of Americans, within the area, the county. Many of whom do not go to the same, their kids don't go to the same school as my kids. But we get together through scouts or through friend groups or whatever else we're doing. So it's pretty good. We sometimes there's a get together for all the employees and things like that. So we have like game nights and whatever else. So there's a lot to do. Whether or not you, I mean, we're not insular by any means. We definitely get out and make friends and go find people. My tea is like right at that proper temperature, so I'm probably going to drink a lot of it in the next half hour. Yeah. There's the moms group, which I have infiltrated. It's all the spouses of the people who are actually working. I mean, working there, but yeah, they send reminders every weekend to go meet up at some local coffee shop or another. And the first one was, "Hey ladies, it's time to plan for this," and I just sent back an emoji of just a bearded man, and they're like, "Oh, right, you're here now." Okay. So that was our discussion for function composition. There we go. Okay. Got worried a sec. I put the stylus down somewhere unusual. No, it's right next to the flight stick, as always. It is not where I should put the stylus. I should put the stylus in the nice little pen holder that I have. All right, so for inverse functions, right, we said that f is going to be defined as taking a set A and mapping it onto B. That's not necessarily literally onto. Mapping the set A in some way, shape, or form, or a subset of set A into, to become, map it over to set B, and find those elements. Well, the inverse function is going to do just the opposite. We're going to start with set B and then map it over to set A. The problem with doing this is that if, right, we must have A must be injective. If we go back and look, it said it must be 1-to-1. Right? Why does it need to be 1-to-1? Well, keeping in mind that when we had stuff from set A and stuff from set B, and we were mapping all these things over here, it was perfectly possible that set A could have two separate elements which end up going to the exact same element on the output. This was perfectly allowed. It's a function. We could do that. But the problem is that if we try to reverse this, again, this being our f, if we try to reverse the process and swap these around, make it set B and set A, then we're going to have one element at the top there, which is then going to map to two separate elements in A. And that is not allowed. Right here, this is a big problem. Whoa. In an interview today for geotechnical work, 2.5 hours long. Oh. Person started talking about being very interested in having you interviewed because he wants you to help IT computer stuff when they looked at your resume. Uh-huh. Systems they use are pretty old and complex, yeah. Now they want you to come a second time just to look at their systems and talk to the IT people. Interesting. This was not part of the advertisement at all. Almost like 2 jobs for the same pay. Yep. My advice would be set some boundaries and like stick with them. So you're going to want to let them know what you're willing to do and what you are not willing to do, or if you are, third option, willing to do this other stuff, but it's going to be at, say, a different rate. You're going to charge like an hourly rate or something like that. Or you have to be a consultant in order to do that other work. They might be a little bit upset about it, but I mean, you need to, in my opinion, not to be taken as career advice, in my opinion, yeah, you should set your boundaries and let them know exactly what you are willing to do and not willing to do, and what you will do, but creative third option. I know at like a couple of other jobs, like I just messed around with like the I was bored at, at a data entry position, so I ended up programming a whole bunch of macros to like just kind of automate my job. It was fine by me because I got to do my master's homework on the side while the stuff was running. I don't know how ethical that is, but like, they didn't care, and my productivity was 5 times what it was, at least, before I did that. So, They also threw a couple of bonuses my way, but I'm sure that I could have told them, like, here's my rate if you want me to keep doing this. Yeah. Yep. I mean, I can definitely understand that. That also might be part of the, unfortunate to say it, but that might be part of the tactic. I know that when you go to like buy a car, they pretty much exhaust you on purpose so that you'll just be like, I just want to get out of here. Sure, I'll pay for whatever extra you want me to. But my spouse and I were pretty firm, like, no, you told us that this was how much we were gonna pay for it, so let's get the paperwork going. You know, don't go talk to your boss 3 more times. This is just, you need to. Hey, Phobos. Yeah, definitely, Hamiltonian. You definitely want to set the boundary before you start, like, actual work. Definitely. Get that, get anything in writing and be like, no, this is not part of my contract. If they try to get you to do extra stuff. And again, if you're like, this can be part of my contract, but you're going to have to, pay me at this particular rate or whatever. Again, maybe since you work there, you'll give them a slight discount because you already work there. It really depends on how you feel about it. Because if it's like, no, this is exhausting work and I hate it, then yeah, charge through the nose. Be like, this is my rate, and if they're like, oh, that's quite a lot, you can be like, yep. It looks like you might have to hire an expert. Children, close your ears. This is usually what you call fuck off money. Yep, looks like you might have to hire some other sucker. Yep. Yeah, I have never had the occasion to drop any particular, um, contract on someone's lap and just be like, here's my scale of fees. Have fun. But the other thing is, like, if somebody wanted to, like, hire me as a private tutor, right? I'd be perfectly happy to do that. Here's my rates, and just let me know if you're interested. Otherwise, you can hire somebody who might specialize in that particular branch. Like, if somebody wants to hire me for differential equations, I enjoy that work so much, and I've taught it so much, that I could probably demand anywhere from 50 to 100 pounds per hour. So, but at the same time, I enjoy it so much that I'd be more likely to put it down to closer to 50. If somebody's like, hey, can you teach me stats? I might be like, tell you what, I can do it poorly for like 20 pounds an hour, but you might want to find somebody else. I'm sure that there's going to be a clause that says other duties as assigned. So one of the things you might want to watch out for is if they, try to tell you something, you need to do this other thing, which is outside of your purview. You might want to say, like, okay, others' duties as assigned within the same department. if you want to, like, you know, get around that and be like, no, you know, if you seriously think that they're trying to exploit you and, like, pay you less than what you're actually worth if you do that other stuff. I mean, going to look at it and just talk with the IT people, like, just doing that, probably not that weird, but if they're like, hey, what do you think we should do? Then you might want to be like, no, I can't. You know, I can't, like, give you advice on this stuff without some sort of actual contract. So my life came to a crossroads in 2010, right at the end there, where I had been offered a position at the exact same place where I was working. They had put out an internal job offer, and I applied for it, and I got hired, like, on the spot, or I got an offer on the spot. Where it was to be part of the fraud detection team for an insurance company. Mostly because I had just done a whole bunch of work on neural networks as part of my master's. So, like, they were really interested. This doesn't necessarily have anything to do with anybody else's situation. But yeah, it was going to be tens of thousands of dollars higher to start, with the opportunity to go much higher if, like, my work proved to be really good. And I'm not saying it would have been necessarily, but I would have enjoyed the challenge of going through all of the I had taken a class in data mining, I took a class in neural networks, took classes in, again, partial and nonlinear differential equations. So, like, trying to puzzle all of this stuff together and create. I probably would have learned Python very quickly, or whatever the IT department was using. Oh god, it was the data entry team was using Visual Basic. It was just, but yeah, that was one of those, like, if you want this job, it is available to you, and we need to hire somebody, like, you know, ASAP. So I'm gonna need an answer in the next week. And I was like, yeah, I really want the job at the community college. So I was like, we're not, you know, I'm not gonna hear back from them for a month. And she was like, yeah, we need somebody to start before that. I'm like, all right. So she said, hey, if that thing falls through, you come back, and, you know, you can definitely reapply when we have a position available. But there were a few of these decision points that it's very fascinating. I mean, just to think about, like, what could have happened. Yeah. I definitely would have kept making the same choices. Pretty sure. Sliding doors moments, yeah. But I was offered a position in for college. I was offered a position at the Naval Academy, like, because my ASVAB scores were through the roof on, like, academics, which I guess. Ended up getting, like, overall 98, 99, 95 or something like that on the 3 main sections. And then, like, all of the individual subject scores were 90s and 80s for, like, a lot of the, like, coding and swiftness. How fast can you copy the following thing? It was like, 80, 90 percentile. Automotive, 38%. 38th percentile. That was not for me. Electrical. I was like, yeah, that's I don't know anything about this. But the guy was like, all right, well, this is just absolutely amazing. Oh, look at these scores, and I'm like, you're not selling this. You need to stop being so enthusiastic about my, like, maybe slightly above average, actually slightly above average scores. Which, like, maybe this guy had never seen anything that high before, but come on. I look at my mom, and I'm just sitting there with my arms crossed like this, and I'm like, and she's like, oh no. And then I took the nuclear engineering entrance exam, and I ended up getting a 48 out of 50 because I had the nuclear engineering merit badge from Boy Scouts. My scoutmaster was a nuclear engineer. He worked at Seabrook Station in New Hampshire. So he, had all of us over and explained how the, system worked. Got all the cool diagrams and stuff like that. We filled in all the blanks. We got to understand how it all worked. And yeah, it was a great time. I loved that merit badge. It was so great. And I retained it. And I like looked up more science about it because it was just awesome. It's one of the reasons that I wanted to go into physics. I was more interested in astrophysics, but, stellar forge, nuclear power plant, it's sort of the same. So, no. But, yeah, so I ended up getting a 48 out of 50 on the nuclear entrance exam, and the guy's just like, oh, this is the highest score I've ever seen. I'm like, don't say things like that. But this was in May-ish of 2001. Yep. So I ended up not taking a commission at the Naval Academy, or, well, I say commission. I did not take a position at the Naval Academy, which, quite frankly, probably would have been a full ride, or really close to it. in May of 2001. It was a little wild. Hmm. Yeah. I think I've also tended to kind of underestimate my confidence for one. Like I've been wondering for a while if I should have gone into like tried for a managerial position like a long time ago, or done something. So we do have in our community college we had course coordinators. So pretty much everybody who is a full-timer, and as soon as they're off probation, they become a course coordinator for something. Usually whatever they've been teaching the most of in the previous 3 years. So you're on probation for 3 years. So I joined up with Precalculus, mostly because the guy who was running it needed a second person, because he was doing this all by himself. And the function analysis class was like had the most sections out of any class in the entire school, or any math class in the entire school. Because like everybody needed to take it if you're doing any science major at all and you haven't already had, or it didn't get into calc. I think like the nursing majors needed it. Most people who were doing any form of eventually to some form of calculus, whether that's the like engineering calculus or whether that was the business calculus, because we have both of those. You're probably going through like the pre-calculus program. There's a whole bunch of majors that required it. So he was like, yeah, I just need an extra person. I mean, this is ridiculous. So he eventually moved on, and then I was given the new guy, who was way more competent than I was. He made really good suggestions just all over the place. I was like, look, I'm going to trust you on like everything. If you want to experiment and try something, absolutely go for it. And so he was all too happy to just like jump and just take. He ended up taking that class, which also redistributed what majors were like needed to take it and things like that. So he was also point with the administration, like the upper administration, to discuss the Head Start program. Not Head Start. That's daycare. Jumpstart. Yeah, we were doing Jumpstart in Maryland, which was to get high school students to come into the community college to take some of our courses and get a leg up on their college education. And this was especially for youth who otherwise might not consider college at all. So it was like basically getting them off campus, getting them to the community college, getting them to get a sense of academic culture. Which, I mean, for a lot of them it worked. It did what it intended to do. It got them interested in college. It got them thinking about college. It got them thinking about their future instead of just sitting around and being like, eh. As soon as I'm done with this place, I'm gonna shake the dust off my heels and get a job at, Walmart or whatever. Hashtag not sponsored. Alright, anyway. So f of x equals y is not going to end up being the same as y2 or whatever equals 1 over f of x. Or inverse, right? Inverse. Not y. Let's just do f. F inverse of x is not going to be the same. As 1 over. So we don't use this as an exponent, rather we're using it as notation, which is telling us that this is the inverse function. If you want the inverse or multiplicative inverse, which is 1 over the thing, most of the time you put brackets around everything and then say it's that raised to the negative first power. Or just literally do that, because it's not ambiguous notation. Right, so instead what we want to do is to find a logically consistent root by which to turn y equals f of x into f inverse of y is equal to x. So this is the functional inverse. You're essentially turning this thing inside out. Whereas, again, this stuff up here, this is the multiplicative inverse. Where if you multiplied f of x and 1 over f of x, then you end up with 1. Asterisk, you need to make sure that the denominator is never going to be 0. Right, for a functional inverse, usually what's happening there is we're going to end up the domain and range sets. So just like we set up there, right? Our B set is now going to become the domain, and it's going to be mapped over to the A set, which is going to be our range. Again, with a slight asterisk, it kind of depends on whether or not it needs to be one-to-one anyway, but it depends on if you're using all of the individual terms. Nah, if it's one-to-one, it's fine. We're all good. I guess you do have to watch out for if there are any domain restrictions because you need to make something one-to-one. Then you just need to watch out for that. Right, this will make sure that f and f inverse are both bijective, because now you have, again, our range set is going to be equal to the image of the domain set. So take your function, plug all of the elements from, in this case, B, well, either way we go, it doesn't matter. Plug all the elements of A in, and we get all of the elements of B, and only the elements of B. And then we said it's one-to-one, so there are no overlaps in either direction. There aren't any overlaps from two things in A mapping to the same element in B, because otherwise that violates the one-to-one idea. And we're not going to have one element in A mapping to two separate elements in B, because that violates the idea of being a function in the first place. So we wouldn't even be looking at that here. All right. All right, define f of x is equal to x cubed plus x minus 4. Given that its inverse f inverse is well defined, so again, these things are one-to-one functions. Determine the value of f inverse of -2. Okay, so the way that I've been doing this with my students is that we say, okay, we want f of x to be equal to our y value is equal to x cubed plus x minus 4. And at this point, we want to be able to solve as best we can for x. So like we did back over on the other side, or like I said, nope, just up there, we want to have f of y is equal to x. This part does get to be maybe a little bit weird. Right, we could also remind ourselves that f inverse of y is equal to x. So therefore, if we do f inverse of -2, we want to solve for the proper value when y is 2. So -2. So we could, in fact, just plug this stuff in like this. I mean, we're better off just moving it back the other way anyway, but nonetheless. Just for fun, this could be x times x squared plus 1. And if you can think of any particular values that work here, you can plug them in and try them. I don't recommend it necessarily, especially for your like go-to move. If you're gonna do it for your like go-to move, it's gonna cause some problems because eventually you're gonna run into a problem where it doesn't work like that. Alright, so here 0 is equal to x cubed plus x minus 2. We do know here that if you plug in x is equal to 1, alright, we're going to get 1 times 1 plus 1. So 1 times 2 is 2. So that does work. It's usually better to do it some other way. In particular, we could, for instance, do division. So we say that, no, that's not what we want. We want x is equal to 1 going into 1x cubed plus 0x squared plus 1x minus 2. If we divide, we end up with a 1, add is a 1, times this is a 1, add them together is a 2, multiply by 1 is 2, and add them together we get 0. So here we could also say that if we factor out an x minus 1, we're going to be left with x squared plus x plus 2. And then here, if we look at this, this is going to be b squared minus 4ac. B is 1, and minus 4 times a times c is going to be a -8. So 1 minus 8 is going to get us a -7. Inside the square root, our determinant's negative, therefore these are complex, non-real. That is also true. If it is a one-to-one function, then there definitely should only be one answer. Because it can't double back again to get us a second. In theory, the exact same value could be a 0 a second time. So, again, in theory, we could have plugged in another 1 down here and said, let's try it again. But we know it's not going to work. First of all, you can look at the coefficients and see that they're all positive. So if you just have something that's going to be multiplying by positives and adding, it's just going to keep getting bigger. So you need to have a negative somewhere to balance this out. Again, unfortunately, it's just not going to work. Alright, complex non-real. So that's the wrong button. This one is then going to get us that x is equal to 1. So therefore, I guess we could go this way. F inverse of -2 is equal to 1. Okay, one more before next break pops up. Okay, let A be the open interval, -1 to 1, and define bijective function f on A such that f of x is equal to x over 1 minus x squared. Find the equation for f inverse that works for all reals. So again, in this case, we have f of x, which is equal to y is equal to x over 1 minus x squared. Here, again, we're trying to solve for x, so we've got to move the stuff at the bottom here, multiply both sides by 1 minus x squared. We're going to get 1 minus x squared times y is equal to x. Right. Not exactly going to work, but y minus yx squared is going to be equal to x. I'm going to shift that one over. So y is equal to x plus yx squared is equal to x times 1 plus xy or yx, whatever we're doing. If we're trying to solve specifically for x, then I think the best bet here is to not do that and solve for the quadratic that we are creating here, which is going to be real weird. Yeah. Yep. You got it, Bob. How you doing? Okay, so we go y x squared plus x plus y. And yeah, treat y as if it's a coefficient. So x is going to be equal to negative b is going to be -1 plus or minus square root of b squared is 1 squared minus 4 A is y, c is y. So 4y squared all over 2 times a, which is y. X is equal to -1 plus or minus square root of 1 minus 4y squared all over 2y. Okay, now that we have it solved for x, this is again f inverse of y. What we can do is instead make a variable change. A lot of my students thought this was a dirty trick, but it works. Alright, ads are about to start. See you in 3 minutes.
And then I was floating down a river of plump white pillows, through a forest of fluffy cushions, under a crystal pendant sky.
So that's the dream you had?
Yep.
And how you want to decorate the bedroom?
Yeah.
Right then, Wayfair it is.
With furniture and decor for every style and budget, Wayfair can turn your home dreams into reality.
Did I mention the light-up inflatable chair?
Get it out of your head and into your home with wayfair.co.uk.
Lean into the sounds you love. Take your playlists anywhere with offline downloads, or play your song of the moment again and again with unlimited repeats. Get all the music without hearing audio ads on Spotify Premium. Tap the banner to learn more.
know that I can't be without you. This bond is solid gold. We're a diamond and an emerald. It took me forever to find you. 'Cause when it's all over, the love that you give will be there to guide you in every way. Now we've been through the cold and darkest days. The summer's calling.
This place is a huge mess, but comes with the territory when you have very arts and crafts oriented children. Alright, so for tonight, a little bit of some Tai Chi because I haven't done it in a long time. So, just gonna loosen up a little bit. Again, basically this is me letting my entire arm weight fall, but then using little tiny movements elsewhere in my body to induce the rest of the motion. So if I actually just stop that, it's just gonna go like that, but we just work our shoulders back and forth a little bit and bounce ever so slightly, and it causes kind of a swing effect. Alright, so let's see if I actually remember this. Start from neutral position, bring our arms up, and down to about here. Going to grab ball of energy and come this way, stepping to the side, and then we come to the front and do a ward off position. This, a little bit more form to it. Here again, this is like this is almost like ballroom dancing. I need to actually straighten out my posture. This is a little bit like ballroom dancing, where you need to like have a form to your body, and then we're going to move this almost as one whole unit. So anyway, we come to the front, we turn ever so slightly further to the right than we need, keep the right hand where it is, and back like this, just a little bit. And then we're going to, what was it? Swing left. How do we get there? Come this way, here. Press to the front, and then drop, push, and sink back. And then we're back to this position, which is where we were, right, where we were at the beginning. So from here, then we can go back to ball of energy, ward off to the front, turn, sink, come back, push. I'm missing something in there, I think. Rock back onto the back leg, and then relax. I need to learn to do that on the other side as well, so I can actually balance all of this. Alright, and then one little bit. So, I am studying Eskrima. Those of you who don't know, it is a Filipino martial art which involves sticks, also known as machetes. So, it is quite interesting. We've got a good bunch of guys. There are 5 of us in total now, 4 plus the instructor, and we generally speaking just have a good time. Make sure that we're actually learning something, yes, but you know, got to make sure that we're enjoying ourselves overall. All right, so we start from this position, and we can do a chase pattern. So while we're doing a standard chase pattern, we can also then drop into a front slash. This is going to be essentially a figure 8 with both of them, and they're passing each other. Can also switch back to here, or what was the other one? Simultaneous chase. Yeah, well, there's the upward slashing one. Gotta make sure we get a good grip. There's Sticks to Heaven. There was our Faint slash, and then Catholic. I think it's Catholic. Again, up top, across the stomach, and Catholic into usually collarbone, or an entire slash across, basically drawing across somebody from shoulder all the way to opposite hip. So that would be quite a nasty one. So from here, it's not really a feint, because I mean you are actually trying to tag them, and it is generally considered a bit cheeky. So says the Yorkshireman. Because most of the time you're expecting a hit from here to come out this way. You're not really expecting one to come from over the top. And if somebody's doing a fan, generally they're trying to block this way first, then come across, then do a Catholic. So, makes it interesting. Anyway, we are hopefully actually going to be able to get back into Eskrima this week. Let's see, last week, well, we weren't here. We were off in Scotland. But our instructor was sick anyway, so he was back from vacation, but he wasn't in. Hey, Pen. The thing didn't go off. I guess you didn't activate it. There we go.
I have a pen. I have an apple.
Woohoo!
Apple pen.
That definitely is a command. I need to figure out what happened. So yeah, we do have a bit of a problem because this is not a function. Now looking at the original, we said this is only going to work from -1 to 1. Which means that this is only going to work for y values. Like our range values will only be from -1 to 1. Yep. Oh, did I mess up? Yeah, I did. Mm-hmm. Yep. Should be a -y. Fair. Alright, so that makes that a positive there. Is that the only thing? Yeah, okay. Well, that makes a huge difference, because having the 1 minus the term in there was going to severely mess up our domain. Okay, so our y values are only going to be from -1 to 1. Oh. Yeah, I suppose. Okay. So if we reverse engineer this just a little bit, say like, oh, where did this all come from?
The dream you had. And how you want to decorate the bedroom. Right then. Wayfair it is.
This is where it came from. This is where that came from. -1 plus or minus square root 1 plus 4x squared. This would have been 1 plus 2xy is equal to the square root of 1 plus 4x squared, absolute value on the other side. Okay. I'm not sure that it helps. Alright, so this stuff is always going to be positive no matter what. So that's easy enough. We never have to worry about what values it's going to have. Okay, so 1 plus 2xy will be positive when xy is greater than negative a half. Now that's saying a lot, so don't worry too much about it just yet. But 1 plus nope. It's gonna be a gross. Negative 1 minus 2xy is going to be less than 0, which is just the same stuff. Wait. I mean, literally it's the same thing, but that doesn't seem right. It's just the product of those two things. So, like, we can't come up with anything really concrete here. The product of those two things must be greater than negative 1/2, or y needs to be greater than negative 1 over 2x. So I know what that looks like. It's kind of gross, but was there any demand? Well, y is only going to go from negative 1 to 1. Unless these are two completely different charts and have nothing to do with each other. But It's not working for all real numbers. Okay. Because according to this, right, there's going to be a gap here. So that can't be it. I could have just deleted all that. Whatever. Satisfied tapping, I suppose. Alright. So this is saying that. Note that square root of 1 plus 4x squared must be... Oh, okay. Must be strictly greater than 2 absolute value of x, which is square root of 4x squared. Oh, yeah, okay. All right. This y stuff in here needs to be bounded by -1 to 1. Okay, so 4 okay. X greater than 0, we're going to end up with square root 1 plus 4x squared greater than 2x. Which if we I hate doing that. Negative 2x is going to be greater than negative root 1 plus 4x squared, which is going to be greater than -1 minus square root 1 plus 4x squared. I think everybody could probably agree on that. we divide by 2x, the positive one, because again x is positive, we get a -1 greater than -1 minus root 1 plus 4x squared all over 2x. Why is that greater? Does not appear entirely correct. So For the negative branch, we still have this, however, that is going to now be negative. Just going to make this a positive 2x. It's going to be greater than negative square root 1 plus 4x squared. Which again is going to be greater than -1 minus the same. And divide by 2x, so we get 1 is greater than.
Get it out of your head and into your home with wayfair.co.uk.
When your deodorant has been reduced to a tiny whisper and tries to tell you, I'm running on empty. I don't have much left to give. No need to worry. Your new deodorant is already on its way. Arriving today with Prime. Everyday essentials delivered fast. It's on Prime. Cut-off times and T's and C's apply. See product page when ordering.
Sometimes I'm selfish, get jealous. I feel a little helpless. My whole world has shifted again. You made a promise, I kept it. Now I'm second guessing. My whole world has shifted again. Now I drop back to an empty room, and it's sedative. Now that your things are gone, what have I done? Was everything worth it?
Ah,
Guess I deserve this.
since we're dividing by 2x, this sign is going to switch. Right, because x is negative. So with x being negative, that's going to have to switch our sign. Okay. I mean, I still think this is backwards here, because... Oh. No, that was kind of obvious. Okay. So, there's a problem here. Namely that all of our Y stuff is exactly opposite the way it needs to be. Yeah, so you're absolutely right, Hamiltonian. Yes, it is the positive branch only that we can look at. The negative branch in both of these cases is causing problems. This is saying that as x is greater than 0, that our y value must be less than -1. And down on this one, our y value must be greater than 1. But that contradicts that. Right, that's the other problem. So we have to use the positive version, so y is equal to, again, f inverse of x is equal to, y is equal to -1 plus only square root of 1 plus 4 squared all over 2x. Okay. Okay. So, yeah, since f of 0 is equal to 0, since we have f of 0 is equal to 0, we must also have that f inverse of 0 is equal to 0. So yeah. How are we going to do that? Well, we've got the equation here, and best way, probably, best way, is going to be to rationalize the denominator. No. Man. We're unrationalizing the denominator, actually, but Okay. Is equal to 1 minus that stuff squared is going to leave behind a 1 plus 4x squared all over a 2x times the quantity, negative 1 minus square root 1 plus 4x squared. Right, we've got a 1 and a minus 1. Those are both going to go away. We've got now a negative 4x squared. No, what did I just... Yeah, okay. Oof. I'm okay. That is, in fact, what we needed to do. Okay. And then we've got a 2x times a... and we can make that a negative out front, so now it's just 1 plus square root of 1 plus 4x squared. Okay, is equal to, that's going to be a 2x up top. Negatives divide out. 4 divided by 2, x squared divided by x. And I mean asterisk. As long as x is not 0, but it literally is, we're trying to do that. So, like, Alright, 1 plus square root of 1 plus 4x squared. Right, in the denominator we get a 1 plus the square root of 1 plus 0, so 2. And in the numerator we get 2 times 0. So if this is, in fact, f inverse of x, then it also means that f inverse of 0 is going to be equal to 2 times 0 divided by 1 plus square root 1 plus 0. So yeah, go with that. Okay. Next time we'll go over on Wednesday. We'll just roll right through this next couple of sections. So the first one is going to be all about graphs of functions. This is going to do piecewise and some other bits. And then the next part is analytic geometry, so doing conic sections, lines, parabolas, circles, ellipses, hyperbolas. Yep. Okay. So we are going to go over and see. Academy of Useless Ideas has been on for 5 hours, so I dare say probably not. They're usually rating over to us. Yeah. All right. We're gonna go over and see Dr. Gold. He typically does SAT prep, things like that. So if anybody has any need for that kind of stuff, stick around and can see how things go. You can win cool stuff. So we'll go see Dr. Gold. Hope to see you all on Wednesday for more mathy type stuff. And I'll probably be hanging out in Dawn's chat tomorrow. Reminder, Dawn has rebranded. Dawn is no longer Dawn Does Math, even though Dawn does do math. Dawn has rebranded to Dawn Factorial. So, those who are interested, we will be going and checking him out on a fairly regular basis. So, hope to see you all then. And Friday night for gamey type stuff, unless I feel like it some other time. So, see you all later. My name's Obi-Wan Pez. This is Simplex Pachinko, and we'll see you next time.